Welcome back to Arxflix. Today, we're diving into a fascinating paper titled Exploring Simple Siamese Representation Learning. This research investigates how simple Siamese networks can learn meaningful representations without relying on typical strategies like negative sample pairs, large batches, or momentum encoders. Let's dig into the core contributions and insights of this work. As you can see in Figure 1, the SimSiam architecture processes two augmented views of one image with the same encoder network. This setup maximizes the similarity between these views, crucially using a stop gradient operation to prevent collapsing of outputs. Collapsing solutions occur when all outputs of a network converge to a constant. Past strategies to avoid this include using negative pairs in contrastive learning and clustering. By contrast, SimSiam avoids these methods and focuses on directly maximizing similarity between views. Remarkably, SimSiam achieves competitive results without the need for negative pairs or momentum encoders. This makes it a simpler yet effective approach in the domain of unsupervised visual representation learning. The researchers highlight the critical role of the stop gradient operation in preventing collapsing solutions. By treating one set of outputs as a constant, it ensures that the network avoids degenerate solutions. Figure 2 shows the impact of using stop gradient versus not using it. Without stop gradient, the optimizer finds a collapsed solution, resulting in a trivial and low-quality representation. With stop gradient, the model achieves a meaningful and well-distributed output. This stop gradient mechanism involves treating Z2 as a constant while optimizing P1. This effectively splits the optimization process and helps prevent collapse. The team conducted several experiments to understand the behavior of SimSiam and demonstrated that it does not collapse under various conditions. They explored factors like batch size and batch normalization while maintaining the effectiveness of SimSiam. Here's a table summarizing the accuracy achieved with and without stop gradient under different settings. Evidently, stop gradient plays an instrumental role in the success of SimSiam. The researchers introduced a hypothesis that SimSiam operates similarly to an expectation maximization-like algorithm. They provided proof-of-concept experiments suggesting that SimSiam could be approximating the optimization of a different set of variables alternately. This equation indicates that the representations are updated in an alternating manner, intrinsic to the SimSiam algorithm. When compared with state-of-the-art frameworks like Simcler, Moco, BeWell, and Suave, SimSiam holds up remarkably well. It even outperforms these models under certain pre-training conditions. SimSiam's simplicity and competitiveness suggest that the Siamese network structure itself might be the fundamental reason behind the success of many representation learning methods. This insight can shift the focus towards leveraging the intrinsic properties of Siamese networks in future research. That's it for today's overview of exploring simple Siamese representation learning. I hope this gave you a concise yet comprehensive understanding of the paper. Don't forget to like, subscribe, and hit the bell icon for more cutting-edge research summaries. See you in the next episode. Thanks a lot to Element for supporting Arxflix and providing this wonderful voice.